Okay, our topic today is frictional force. I believe you can see the board. Can you see the board, please? I don't know if it's too visible. I don't know. Good afternoon, everyone. We want to proceed with our class. Today we are going to look at frictional force. Okay, but before I proceed, I want to know those that's online so that we can proceed. Okay. All right. So if you're online, just say hi, hi, hi. Let's see you so that we can start. Victoria SCN, how are you? You're welcome. SNO ones. What is frictional force? Okay. Okay, thank you. Let's just start the class. Okay, Peculiar, how are you? Okay. All right, let's just start the class. You can double tap on your screen to give it a like and make sure you subscribe to this channel, okay? So let's proceed. Welcome, everyone. Today we're going to look at frictional force. Frictional force, okay? So we can't just go into frictional force without explaining what is a force and what causes force and the type of force, okay? So what is a force? A force is an agent that change the position of an object. Is an agent that can change the position of an object. Okay, a force is an agent or anything that can make an object to change its position. That is said to be what? A force. And we have types of force. I'm going to write it on the board. I just want to explain. We have types of force. We have contact forces and non-contact forces. When we hear contact forces, is a body that require contact with the body to which they are applied. Contact is just like when you are holding any object and the force take place, becomes contact. For example, push, pull, tension, reaction, friction. They are all under the examples of contact forces. Okay? Then under non-contact forces, they are forces that do not reach contact with the body to which they are what? Applied. We have just three examples under non-contact forces. We have electric force, gravitational force, and magnetic force. So I'm going to put down everything and explain it again before I go to the concept of frictional force. Is that okay? So stay tuned. All right, so let's explain what we have on the board. Force can be defined as that agent that changes or tends to change the state of rest of an object. Okay? Any agent that changes or tends to change the state of rest of an object is said to be what? Is said to be a force. Okay? So, an object that is on its own cannot experience force except something that is stronger than it tends to move its position or its state, it becomes what? A force, right? It will not change its position or it will not move. That is what we say to be force. Now, what are the effects move a body? Yes, a body that is on its own can move with what? With a force. A force can change the direction of motion. Yes, a body that is moving is can start moving or can be asked or can move or change to start moving what? Not if you apply force. That's what I mean. Force can change the shape of a body. Yes, we can apply force on a body and the body will change its shape. And finally, force can stop a body from moving. A body that is in motion can tend to stop moving when you apply what? Force. For example, if you kick a football, the football is going to move, and let's assume that this is a vertical wall. The football move and hit a vertical wall with a force, and it's going to stop what? Moving. So these are the effects of what? Force. Okay, so I'm going to explain or write down the types of force with their examples. Please, if you are just joining, just give it a thumbs up. Like the class. Double tap on your screen. Thank you so much for coming. Please, you can copy the notes. I don't know if network is bad. Copy the notes so that I can explain. All right, let me just explain. Okay, so we have types of forces. We have two types of forces. Number one is contact forces. And number two is non-contact forces, which is also known as force field. So let me explain the contact forces. These are forces that are in contact with the body to which they are applied. For example, before these forces can take effect, there must be contact. That's what it's trying to say. Before these forces can take effect, there must be contact, okay? For example, I have push, pull, tension, reaction, and friction. These ones are under contact forces. Before they can take place, there must be contact. That is why it is called contact forces, okay? Then, under it, that is where there must be contact. Now, let's go to non-contact force or force field. Non-contact forces or force field. These are forces, or they are forces which are not in contact with the body to which they are applied. Now, these non-contact forces of force field, they don't need contact with the body to which they are applied. They don't need contact, okay? So you don't need to hold them or to touch them before it can be experienced. For example, electric what? Force. Now, for electric force, you don't need to hold electric before the force will what? The force will be experienced. When you are in the field of electric, you can experience electric field. Now, magnetic field, magnetic force. If you see a magnet and get small ion fillings, small grated iron, that is what's called ion fillings, okay? Then you can just bring it close to it. You see attraction that will take place. You don't necessarily need to touch it before it will take place. Then gravitational force, okay? There's a saying that says that anything that goes up must surely come down. Up now, it will do what? It will come down. I did not bring it down. But because of the force of gravity that is acting on it, it makes everything that goes up to do what? To come down. So I don't need to touch the gravity before it will act. It is already there. So these are classified under non-contact forces or force field. So our topic today goes back to frictional what? Force. I'm going to explain what is friction and relationship between friction and what? Reaction. Okay, some side of the body is not showing. I'm gonna go get you. Thank you. Peculiar, Peculiar, can you see it now? I don't know if you are seeing it clearly. The way my body is showing is not the same as yours, so I don't know if it's clearly seen now. Peculiar, can you see it well now? Are you seeing everything right now? Please, Peculiar, can you see? Are people seeing the board clearly? Everything on the board clearly? If not, let me readjust the camera so that I can see it well. Is he okay now? I don't know who is online now. Is he okay now? Can you see everything on the board, please? No, ma. It's okay. I'm seeing no, ma. So I don't know how to. Okay, so that means I will not write beyond that side so I can see it clearly. Okay. So let me proceed. If you are just joining us, just give it a thumbs up. Double tap on your screen to like this class or this live stream. Thank you for coming. All right, so let's explain friction. Okay, I've drawn a line now. I don't know if can you see the two lines, please? Let me work on it. So I will not exceed that end. Can you see the two lines on the board? Please, who is online? Answer me. Okay, Chionwuka, can you see it, please? It's fine, you can see it. Okay, you can see the two lines. Okay. Agnes, Mina, okay, you can see it. Okay, you can see, okay, let's work with that. So I will not exceed that. Victoria, say it's worse now. Maybe times. Please, Victoria, check your network and see whether it's coming from there. Okay, so let me explain. If you are just joining us, please, okay, it's clear. double tap on your screen or you like this live class. Okay, thank you for joining. Now let's explain friction. Friction is defined as a force which acts at the surface of separation between two objects in contact and tends to oppose the motion of one over the other. Friction is a force which acts at the surface of separation between two objects in contact and tends to oppose the motion of one over the other. That means this friction is doing two work. One, it is what? It separates two bodies in what? In contact. It separates two bodies in contact. Okay? Now, it tends to oppose the motion of one over what? Over another. Now, frictional force must act between two bodies and they must be in contact. Meaning, these are two bodies, one, and this is another body, two. They are in contact. Once two bodies are in contact, force will act on them. Now, there's one thing you must know about friction. The two bodies must not be of the same nature. How do I mean? It must be what? Smooth. While the other surface must be what? Rough. Okay? So that it can work well. Now, what is this friction? It's a force which acts between the surface of separation. This is separation between two objects in contact and acts on the motion of one over the other. Now, it opposes the motion of the other. If this is moving on this, it is opposing the motion of this over this. That's what it means. So we can say that friction is a force of opposition. Friction is a force of opposition. Let me put it down. Now, we have to note these things, that friction is a force of opposition. It does not appear unless there is a relative motion. So friction does not appear unless there is a relative motion, and it's also a force of what? Opposition. Its work is to oppose the movement of the other. Okay? Do we understand? So let me use an illustration to explain what I mean by that. Agnes, Mina, it's not clear. Check your network. Okay. Ajoku, you're welcome. Also, Emeka, you're welcome. Please, if you are just joining, just like the class. Double tap on your screen instead. It will come up. All right, and make sure you subscribe to this channel. So let's proceed. Okay, let me explain the diagram we have. This is a block of wood, and this is a horizontal surface. It's just like carrying a wood, putting it on the ground. Then you now drag it. Direction of motion means that this block of wood is dragged this way. That's this direction. Okay? But the frictional force, because it's a force of opposition, right? The horizontal surface is a rough surface, but the log of wood is a smooth surface. So because this is going this direction, frictional force will go opposite of this direction. That is why this direction is going this way. So this is the frictional force. Okay? Now the weight of this object is always acting down because weight acts downwards. So the weight of this object is acting down, and the reaction of the object on the horizontal surface is acting what? Up. Do we understand? Let me go again. I said this is a horizontal what? Surface. And we have a block of wood placed on the horizontal surface. And we now drag it on this direction. This is the direction of motion. But because friction is a force of opposition, it must go this way, opposite of the direction of the motion. Okay? Now, the weight of the body is still acting down because weight acts down, while the reaction is acting what? Up. Do we understand? So that is the concept of what? Friction. That is the concept of what? Friction. So from a law of friction that states that what? The frictional force F is directly proportional to the normal reaction R. Yes. The frictional force is proportional to the normal reaction R. And the reaction is the same thing as what? Weight. Let me put it down. The frictional force is directly proportional to the normal reaction R. Now, what do I mean by that? I mean that this F, frictional force, is proportional to the what? To the normal reaction R. Okay? That is proportional to this. But the R, which is reaction, is also equal to the weight. I can say that reaction is equals to the weight. And weight is equals to mass times gravity, or mass times acceleration due to gravity. Now, if you know that, in physics you must have a proportionality sign, and you have to remove it and introduce a constant. So how do we introduce a constant? You can introduce a constant by removing this proportionality sign, okay? So I will have F is equals to mu what? R. Do we understand? Okay, I will go back to explain it. Okay, you say, why is it going left? Okay. Friction is a force of opposition. It must oppose. That is its work. The direction of the motion is going this side. Friction cannot go the same direction as the direction of motion. It must oppose it. So if the direction of motion is going this way, friction will go what? Will go back. That is why it's going left. Do you understand it now? Get you? Because the direction of motion is going this way, so friction is always going what? Opposite to direction of motion. So it's going to go what? Back. To oppose this motion, that is the work. You want to oppose the motion of this movement of a block of wood. So it must go this direction to oppose it. Do you understand? All right. And I said from the law of friction, that said that the frictional force is directly proportional to the normal reaction R. Now that is F is proportional to R. And I said that R is equal to the weight. Look at it. R is equal to the weight. What is R? Reaction is equal to the weight. And what is the weight of an object? The weight is mass times acceleration due to gravity. Okay? Now what is F? F is friction. In every law in physics, you have to remove the proportionality sign and introduce a constant. And if you introduce that constant, you're going to remove this proportionality sign and put in a constant. That constant is what is said to be mu. That mu is the coefficient of limiting friction. R is the reaction, and F is the frictional force. I don't know if you understand. All right, I'll still go back to explain it. Okay, the block is going its own direction, Ogechi, and the friction is going opposite to that direction. Okay. Now, why can't we use K to represent a constant? You know, in physics, we have so many constants in physics. So we decided to use mu to represent this constant for friction. Okay. You are still going to see this constant again when you proceed in physics. That is in SS3. You're going to see this constant again in a topic called capacitors and capacitance. So, but now we are making respect to it in respect of what? Friction. Okay? All right. Also, like I said, the view is blurring. Can you check your network? You can on and off it. I don't know if it's better now. Can you see? Okay, let's explain what we have. Okay, we have the laws of friction. The first one, friction opposes the relative motion between two. I've already explained that, but let me still go back to explain. When I mean two surfaces in contact, it means when two bodies are in contact, okay? So friction tends to oppose the motion of one over the other. Number two, the force of friction increases to the same extent as the force which tends to start the motion. So the rate at which the force of friction increases is the same as the force which starts the motion. And the force that starts the motion is the force that's dragging that object to its own direction. So friction is also going its own direction, which is opposite to the other. All right. Number three, frictional force depend on the nature of two surfaces in contact. Okay, it depends on the nature of the two surfaces in contact. Depend on the surface that are in contact. That is how you can use to explain what friction. Then the next one, it is independent of the area of the surfaces in contact. Independent of the area of the surfaces it does not depend on the area in contact. It does not depend on the area in which it is touching the what, the ground or the other surface. Do we understand? All right. Okay. All right. I can see your comment. Okay, Victoria, I am blocking you. Okay, I'm done with the explanation. You can now copy. I'm giving you a little time to copy now. Okay. All right. Agnes, after now, in any of your classes, can you do a little review on measurement, velocity, and time? Okay, Agnes, I've made a video on measurement, velocity, and time. Maybe after this class, I'm going to send the link of that particular video to the group, okay, so that you people can watch it. Then after watching it, you give me a feedback. If there is still something you do not understand, then I will now explain it in any of our live class. Do we understand? Is that okay by you? I don't know if it's okay by you. After this class, I'm going to send a link of maybe tonight. Tonight, I'm going to send the link of the video I made on measurement. Everything on measurement, I've explained it. Okay? So you're going to look at it and tell me whether you are still lost. If you are still lost, then we agree on the day we're going to do that. All right. Thank you so much. All right. Are we done copying so we can proceed? I can't see the last line. That is number 4. Emeka Wosu, is that number 4? Okay, let me read it out. Number 4. It is independent of the area of the surfaces in contact. That's the last one, number 4. it is independent of the area of the surfaces in contact. Okay, Agnes, we can proceed. All right. Peculiar Essien, are you done? Are you done writing? So I want to proceed to the next one. Okay, so let's proceed. Okay, I'm already playing it. That's the last one, number 5. Yes. Okay, Chamuka, yes, I'm doing class every day, even on Sunday. But I'll tell you the time you're going to have tomorrow on the group. That's why I have the group. Okay. All right. Okay, let me explain. It's number 5. Friction varies directly with the normal reaction pressing the surfaces together. That is, it is proportional to the normal reaction R. Okay, I've already explained it that the frictional force is proportional to the normal reaction what? R. And I said in every law in physics, once you have a proportionality sign, you are going to remove the proportionality sign and introduce a constant, okay? And the constant we choose to use in this concept is what? Mu. What is mu? That is the coefficient of limiting friction. Now where F is frictional force R is reaction. Reaction is actually a force. I can say reaction force. Then the mu is what? Coefficient of limiting friction. F is the frictional force, R is the reaction force, and mu is the coefficient of limiting friction. Okay? SN, okay? That evening, will you be online so that you can be answering us immediately? And by that time, are you going to send it so that we will schedule our time? Yes, I will tell you the time this evening against tomorrow so that you will know on time. Then we all plan towards it. And it will be online and live so that I will be answering your question immediately. If you are just joining us, please don't forget to like this class, double tap on your screen, and give it a thumbs up. All right, so let's proceed. I believe you are done writing. Okay, I'll send you the time for tomorrow. After today's class in the evening. Firm grip. Okay, it's firm grip. It's firm grip. Okay. It's friction. It's friction. Peculiar is friction. Are we done writing so we can proceed? I want to explain. Okay. Now, the first advantage is this. Without friction, it will be impossible to walk or stop walking after getting started. What do I mean by that? If you are walking on a clay soil, with a bare foot, you see that the your foot, or your foot rather, is a smooth surface, and clay soil is also smooth. So by the time you walk on it, even on a mud, inside the mud, you see that it's very difficult for you to walk because the two surfaces are smooth. Okay, so for friction, one surface must be what? Must be rough, and the other surface will be what? Smooth, for it to take its effect. Okay, all right. To make a firm grip on the roadway, that's what I'm saying. The tires of our car is always a smooth surface. Look at the body. It's smooth, very smooth. Okay. Now, the roadway is rough. So because of that, friction can take its place. Do we understand? In as much as we have two surfaces in contact, one acting over the other, we have friction. All right. Number Friction is utilized in farm belts, used over wheels in machineries. Yes, friction is utilized in farm belts, used over wheels in machineries. Most of the machineries we use, they use wheels that make respect of what? Friction. And friction always utilized in machines. Something that you can apply oil to lubricate it. Okay? Back to that, under the effect is in reducing friction. So let me conclude on the advantages of friction. All right, can you copy first? Let me explain. All right, let me explain. Number 4, friction enables a nail to remain in position after being screwed into, to remain in place rather, after being screwed into position. Okay? For example, if you screw a nail, because a nail is a smooth surface, you screw it inside a wood or any particular position, it will remain there because of what? Friction, because of the two surfaces. Okay? Number 5, friction enables the brake to stop a car. With the help of friction, the brake can actually stop what? A car. Do we understand? Okay. So friction is used in the grindstone to sharpen knives and chisels. Now, because of friction, we can sharpen knives and chisels in the what? In the grindstone. Okay, so you can use your knife and sharpen it in the what? In the grindstone. It's going to be very, very what? Sharp. That these are all the advantages of friction. So let's look into the disadvantages of friction. Allokins, I'm teaching SS1 right now. Which class are you? Okay, Victoria Essen, if you need to be present in all the classes, if you choose to, but I splitted this class by class so that you can be able to understand based on your level. Okay, I'm taking SS1 right now. By 4 o'clock, I will proceed with SS3. Okay, so we will soon end the class. In a few minutes, and we'll be done. Okay, SS1K. Hey, all right. This is your class. We started since 1 o'clock. Since 2 o'clock, sorry. We started since 2 o'clock. So this is for your class. Okay? All right. Okay, Ifes, you are welcome. You're welcome. Please double tap on your screen to like this live stream. They are just coming. Okay. Okay. Eze Kingsley, I will send the time on the group, okay? Peculiar, I understand. I will send the time on the group. All right. Now let's look at the few disadvantages of friction. Disadvantages of friction. Disadvantages of friction. Friction, number one, friction leads to wear and tear on the moving parts of the machine. Wear and tear on the moving parts of the machine. For example, if you're using a machine and you do not lubricate that machine, you don't have a lubricating the machine. You're going to wear and the turn. Machine will just spoil because of what? Friction. How do I mean? For those people that are, okay, let me say tailors and seamstress that use machine regularly to sew clothes, they need to lubricate that metal part. If not, they will make that machine to break down. I have to go for repair. That's what I mean. Okay, so the friction in the moving parts of the machine causes wear and tear, and that is why there is need for us to reduce the friction before we can work effectively. And because of friction, the efficiency of a workable machine cannot be 100 what percent because of what? The work done against friction. So you see that we need to reduce the effect of friction in any machine before we can work effectively. That is number one. Number two, much useless work is done by the machine in overcoming what? Friction. Now, let me also use the seamstress for example. If you do not reduce the effects of friction, it can take you 2 3 days to sew one cloth without their sewing machine because of the what? Friction in the moving parts of the machine. So there is need for you to do what? To lubricate it. So if you decide not to lubricate it and to reduce the effect of friction, you will work tirelessly for you to sew a particular cloth. It's going to take you a longer work time, and that time that you have wasted is a time that you will have used for some other things or more of 5 clothes. Do you understand? So there is need for us to avert this friction and to reduce the effect so that it can work effectively. Number three, friction causes the heating of engines. Friction can cause engine to do what? To heat up. That is always need for us to look at the ways in which we can reduce friction. So these are the disadvantages of friction in our machine. So there is need for us to reduce it. So that leads us to ways of reducing what? Friction. How can we reduce friction so that our machine can work effectively? So that the efficiency of our machine will be at least 100%. Okay, the class will end in few minutes time because I have SS 3/4, so I'll soon end the class. I just want to explain what is on the board then. Okay, they say there is no work after this less. Okay, sorry. And I've cleaned this already. I didn't see it on time. Sorry for that. Okay. Okay, Chionwuka, you're not on the platform. Okay, maybe I should I call my number or should I write it? Okay, Chionwuka, can you drop your auntie's number? Let me just add you now after the class. Can you just drop it? Drop it for me right now. Let me just take it down and add you. Okay, I'm waiting. Just drop your number so I can add you immediately. I want to end this live stream. Okay, so these are the ways in which we can reduce friction. One, the use of lubricants like oil, grease, air, and graphite. How do we use these lubricants? By touching it on the metal part of our machine or engines, okay, so it can work effectively. Number two, the use of ball or roller bearing, still the same thing. Then the use of the streamlining of body shapes of moving objects. So these are the ways in which we can reduce the effect of friction. Okay, don't forget that friction is a force of opposition, and don't also forget that friction acts between two surfaces in contact. Okay, and also don't forget that friction is acting in friction is directly proportional to the normal reaction. In my next class tomorrow, I'm going to explain that concept well so I can help you to solve calculative problem on friction. So don't miss tomorrow's class, okay? Then what again? We should know the advantages and disadvantages and ways of reducing friction. And we should not forget that friction is under a contact force, and contact forces are forces that do not need contact with the body to which they are applied, okay, while non-contact forces are forces that need uh, contact forces are those forces that need contact with the body to which they are applied. They must be in contact with the body to which they are applied, while non-contact forces are forces that do not need contact with the body to which they are what applied. Okay, all right. Okay, so instead I should give example for number 2, ball bearing. Okay, so example of ball bearing is like there's a machine called wheel and axle, and that wheel and axle takes to do what? Is like it takes to rotate. Okay, it takes to rotate. That is SS2 topic under mechanical energy. We still have, we're going to apply the knowledge of friction there. So the machine tends to rotate. So this ball bearing is that they made in such a way that the machine will not be touching each other. If the machine touch each other, it's not going to rotate again. So if it is shaping in such a way that it cannot touch each other, it can move comfortably, thereby reducing what? Effects of what? Friction. That is what number 2 is all about. Okay. Yes, okay, Chonwoka, I'm done with the class. I just want to end the live stream so I can prepare for the next class. I'm waiting for the number. Can you type in your auntie's number so I can add you up immediately? Okay, ma. Okay, sorry. Okay, there, no problem. She refused. I will end the live stream. Then I will send her a notification. Tell her to subscribe to this channel so that each time I post video, she'll be notified, okay? That is the only way you will know. All right. See you guys next time. Thank you so much for joining this class. I really appreciate. I'm going to see you people next time in my next class. Bye for now.